Hello there, welcome to College Algebra, section 1.7, part 2 with Gregory Carlson. And we are solving x squared is less than or equal to 20. Alright, so there's something kind of extra going on in this problem because of the x squared. And I'm going to explain this a little bit more thoroughly when we get to absolute value in section 1.8. So if you don't understand everything I'm about to say, it's okay. We'll cover it some more in the next section. But essentially, do you see how this x is less than? As x gets bigger, it's eventually not going to work anymore because we have to be less than 20. We're being constrained by 20. Whenever x is being constrained like that, it means we're looking at an AND problem because x is being constrained. So let me show you how to solve this. As usual, you would take the square root of both sides like this. All right, and the square root of x squared is x, which would give me x is less than or equal to the square root of 20, which is 4 times 5, and we can zap that 4 and get a 2. So x is less than or equal to 2 root 5. But you'll remember that when we take square roots like this, we get a positive and a negative answer. Do you remember that? So the negative actually serves to flip the sign. Okay, so it flips the sign and we're less than or equal to 2 root 5 or bigger than or equal to negative 2 root 5. Remember, 2 root 5 is just the square root of 20 reduced. And that negative sign is kind of like multiplying by the negative, which flips the sign. So here's where this gets a little bit confusing. Let's put these in interval notation, where everything from negative infinity all the way up to, where x is less than or equal to 2 root 5. So there's answer number 1. This is where everything bigger than negative 2 root 5. So that means that we're going from negative 2 root 5 all the way up to positive infinity, like that. Okay, so this interval right here is this piece. This interval right here is this piece. And oops, I should have put a bracket right here because we are including the answer because of the equal sign. So that should have been a bracket. All right, now here's where it gets tricky. Remember how I said this was an AND problem? What we need is the overlap of these two intervals. So our first interval, I'm going to draw 2 little number lines. Our first interval was negative infinity up to, here's 0 in the middle, up to 2 root 5, which 2 times the square root of 5, let's actually see what that is really fast. There's the square root of 5 times 2, so it's about 4.4. So here's 2 root 5, and notice that it's in a solid dot because we have a bracket because we're including it. So we are everything smaller than that, and we're everything bigger than the negative 2 root 5 and bigger than that. So this is an AND problem, so I need the overlap of these two regions. And the only place where they overlap is here. You need to be an answer on both parts in order to be an answer to the entire thing because it's an AND problem. So here the overlap is from here to here. So here's the final answer. That's the answer. As soon as you get smaller than negative 2 root 5, this is no longer going to be true. Like if you put in negative 100 here, negative 100 times negative 100 is a huge number that's no longer less than that. If you get bigger than 2 root 5, this squared is 20. So that's going to give you 20 equals 20. Anything bigger than that, and it's not going to work. So we're constrained. Our interval, we're captured in this tiny window, and if you get too big on either side, it's not going to work. And notice that some negatives will work, because when you square them, they make it positive. And so I know that's okay if that doesn't totally make sense. Let's look at the next one, and then I'm going to show you one other thing. Now, notice on this one, the x is bigger than the number. On the previous one, the x squared was less, so it was an AND problem. We're being constrained. Here, we're being explosive. This is an OR problem. x squared has to be bigger than this number. So when we take the square root of both sides, the square root of 49 is 7, so we get x is bigger than 7, or x is less than negative 7. And notice that for the negative, I flipped my sign like I did last time. Now, because this is a bigger than, we have an or problem here as opposed to an and. So that means that as long as the solution is one or the other, it's going to work. So unlike this one where we had to find the overlap, this one you can just put both of the answers down. So let's see. The first one is x is less than negative 7, which would be negative infinity up to negative 7. Not included because we don't have an equal sign. And the other one would be everything bigger than 7. Parentheses on everything because we're going from 7 and bigger. So this second one is here. This first one is here. And we can put them all in one line by using that union operator. So start with the negative one. Negative infinity to negative 7, or 7 to infinity. So what's the difference? With the AND problem, we only had this one interval. With the OR problem, we had two intervals. Let me show you really quickly sort of kind of why that is. Going back to our original problem, x squared is less than or equal to 20. If I were to subtract this 20 over, I would get the following. X squared minus 20 is less than 0, right? Does that make sense to you? X squared minus 20 is less than 0 if I just ignore the square roots, if I just move the 20 over. The graph of that was kind of sort of looks like this, if I were to graph it. So in other words, if I were to replace this 0 with a y and graph this parabola, it would look like this. And I want to know, when is the parabola less than 0? Okay? And you can see that it's less than 0 in this little interval right here. That's capped off here and here. So that's why the answer is from negative 2 root 5 to 2 root 5. It's just this one interval. If I flip this sign right here, suddenly I'm asking, when is this bigger than 0? And you can see that it's bigger than 0 on these two branches with a hole in the middle. That's what's happening with this problem. That's why we have two branches with a hole in the middle, because this parabola is going underneath, and these two branches are where it's bigger than 0. So you can see that everything is dependent on which way that greater than less than sign is pointing. If I were to graph this one, if I moved the 49 over and graphed x squared minus 49, it would look like this. Same thing, except we're crossing at 7 and negative 7. And it wants to know, when is that x squared minus 49, when is that bigger than 0? And it's bigger than 0 on these two branches, which are represented here with this hole in the middle. And notice that these are outward facing parentheses because we don't have the equal sign. So hopefully that makes sense. Again, I plugged in a y here to graph it. It's important to realize that the answer is going to be one of two things when you have an x squared and an inequality. It's either going to be an and interval in the overlap, like we had here, this overlap, or if it's an or, it's going to be these two branches. And I'm going to explain this again in absolute value, so if you don't fully understand it, that's okay. Everything is dependent on which way that sign is pointing. If x is less, we're constrained, and we're in this and interval. If x is bigger, that is explosive. We have lots and lots of answers on these two branches with the hole in the middle. So very quickly, I'm going to solve this one without all of the hullabaloo of what we just went through. To get rid of this, first we want to get rid of the fraction, so multiply by 5 plus 4x on both sides. This one's going to be easier because we don't have x squareds. So whoops, cancel both of those. So 16 is less than or equal to 8 times 5 plus 4x. Do the distributive property. So 16 is less than 40 plus 32x. Subtract 40 on both sides. And 16 minus 40 is going to be negative 24. and then you just want to divide by 32. So I believe, let's see, 24 divided by 32, I believe 8 will go into both of those. Whoops, 24 divided by 32. Yeah, so it's 0.75. So 8 goes into both of those, so you get x is greater than or equal to negative 3/4 or negative 0.75. So sorry, the reason I paused is because I did that wrong on my notes. So I have to, now we need to be careful here. So let's write this in interval notation. X is bigger than negative 3/4 and equal to, so this should be a bracket, not a parenthesis. So we go all the way up to infinity. So this is great and all, but you may remember there's one number that x can't be. See this down here? This could be a problem if this denominator is 0. So let's solve. Let's solve 5 plus 4x equals 0, minus 5 minus 5. 4x equals negative 5, divide by 4, divide by 4. So x cannot equal negative 5 over 4 because that would make this denominator be 0, which would be undefined. But here's the good news. This one problem, negative 5 over 4, that's going to be to the left of this. Because do you see how that's a bigger negative number than that? So this number is already not in our interval. So you can just write this as your answer because we got lucky that this number is not in the interval. But it's a good idea to write it down just to prove to the math teacher that you're really smart and that you know that there is one number that would be undefined here. So it would be a good idea to also make a note of that. But in this case, we were okay because our number was not in this interval. If for some strange reason this had been in the interval, you would have needed to break it up and use a union symbol like I showed you at the end of interval notation. All right, I am way over on time. We have a few more problems to go, so I will see you on part 3.